Welcome. So this is the change of base formula. And the reason that we have a change of base formula is because some bases are a lot easier to work with than others. Right? So with this formula, you can change the base of any logarithm to one that's easy to work with, namely base 10, or, which is just log, with no subscript, or base e, which is natural log. And why is base 10 and base e easy to work with? Well, they're used so much. One's called the common log, the other's the natural log, that they're the ones in the calculator. Any calculator, any scientific calculator's got log and natural log. So you don't need anything fancy. It's super easy to evaluate. And change a base formula, it's really easy to use. So the same formula can be used to convert to either of these two bases. Right? And it doesn't matter which one you use. Right? I have a tendency to use one more than the other just because I write it that way. But either one works just fine, the common log or the natural log. And how you set it up, so here we have log base A of m, right? In the numerator, so you pick one, base 10 or natural log, you're going to put the result. So log result over log base, or natural log result over natural log base. And if you have trouble remembering that, the big number over the little number, because your base is the little number. All right? So super easy. Let's use the change of base formula. And by the way, you will need a calculator, right? But it's really easy to plug into the calculator, and it's really easy to set up. And I'll even give you a way to evaluate whether or not your answer makes sense. All right, so evaluate with the change of base formula, right? So that's the exact, that's an exact number. There is an exact number represents log base 7 of 34. But unfortunately, that number is irrational and never ever terminates, all right? So, but we can, and somehow reason I erased half my sentence here. And meanwhile, I'm going to fix this because in my zealousness in erasing, I erased half of what I wanted to put up here. Right, so you can check yourself by asking if your answer makes sense. I just needed to fix that because I didn't even notice I erased half of it. But we need to first use our change of base formula, all right? So it's, and I'm going to do all of these in both just so you can see and put in your notes, do all of them in both. But then when you're actually evaluating, you pick. All right, so it's going to be log of result. So log 34 divided by log 7. Or use natural log. Natural log 34 divided by natural log 7. Now what are you going to do with that? You're going to plug it into a calculator. All right, and so this is what it'll look like. You're going to hit log, and automatically a parentheses will come up, and you type 34, and you close your parentheses, and then you hit the divided sign, and then you hit log, and automatically the first half of the parentheses comes up, and you type in 7, and you close your parentheses, and that's going to give you an answer. And it'll be the same thing, right, if you use natural log, except it will say natural log instead of log. Right? And so this is what it looks like in the calculator. That's what you're going to type into the calculator. And when you do that, the calculator is going to give you an answer. And the answer the calculator is going to give you, as soon as I grab a calculator, is 1.8122. All right, so now let's talk about, does that answer make sense? All right, so now let's think here. All right, so what that means is 7 to the 1.8122 power equals 34. Well, that's not a really nice number there, 1.8122. And by the way, that's I included 4 decimal places. 4 decimal places is fine. All right, this actually keeps on going. I know that 7 to the first is 7. and 7 squared is 49. All right, so 7 to the 1.8122, right, is larger than 7 to the first power and smaller than 7 squared. And that makes sense because 34 is larger than 7 and smaller than 49. All right, so that's how you can tell if your answer makes sense. All right, now, so if I made an error, let's say I accidentally hit log on one and natural log on the other, and I got something like crazy, like 5.2, I'd go, oh, that can't be right. It's got to be less than 2 because 7 squared is 49. Can't be more than 2. Right, so that's how checking, asking yourself if your answer makes sense can help you out. All right, let's try another one. All right, so how you evaluate is you take log base 10 there, 95, the result divided by log 2, or take natural log, 95 divided by natural log 2. Now you can plug it into the calculator because you have a base that's in the calculator. All right, and when we do that, I need a calculator. I meant to write them all down. All right, but I forgot. But that's okay, it doesn't take too long. It's just hard to hold a microphone and a calculator at the same time. Oops, I forgot our parentheses there. So log 95 divided by log 2 gives us 6.56, and then it's 985. So I'll do 99. All right, 6.5699, or I guess you can round that to, well, that's fine, 6.5699. All right, so let's see if that makes sense. All right, so I know that 2 to the first is 2, and 2 squared is 4, and 2 cubed is 8, and 2 to the fourth is 16, and 2 to the fifth is 32. I keep going here. 2 to the sixth is 64, and 2 to the seventh is 128. All right, so let's see. So 2 to the 6 is less than 2 to the 6.5699. That's a 5. And that's less than 2 to the 7th and 64. Oh man, look at that 6. I'm leaning over too much. 64. Oh, I don't know how I hit that. 64. Cancel. I have no idea how I hit that. I was simply writing 64 is less than 95 is less than 128. I'm amazed at my own powers here. All right, so 64 is less than 95 is less than 128, and 2 to the 6.5699, that's greater than 6 but less than 7. All right, so our answer makes sense. All right. All right, we should have something in between 6 and 7 because 95 is in between 64 and 128. Let's try another one. I don't have too many more. All right, so I'll write in red this time, I guess. All right, so to evaluate, use base 10, log 112 divided by log 5. Or you can use natural log. Natural log 112 divided by natural log 5. All right? It's because that ratio of the result and the base are going to be the same as whatever log base 5 of 112 is. And so now I need a calculator. So in the calculator, I clear my last answer. All right, so I'll hit natural log this time. Natural log 112, close my parentheses, divided by natural log 5 gives me, and you can, by the way, try this with me, so that way you make sure you know how to use your calculator. You got 2.9318. So let's 917. So let's do 2.93 and 2. 2.932. All right, so base is 5. So I know 5 to the first, that's 5. I know 5 squared is 25. And I know 5 cubed is 125. I'm just multiplying. You just multiply 5. Multiply by 5 each time. And so 5.2 should be less than 2.932, which should be less than 5 cubed. So notice I went just past what my answer is there. And 5 squared is 25. That is less than 112, which is less than 125. Now notice how much closer 112 is to 125. All right, so 112 is closer to 125, and you can add all this into your notes, than 25. So the exponent, so our answer should be closer to 3 than 2. And it is. All right? So by the way, I packaged all of these into one lesson with the one that you need first last. And the reason that I did that is, well, I already had some recorded, and I had a really nice intro. And I kind of forgot about my intro, and I wanted to include that intro. So as you're taking notes, this one happened to be right on the front page, make it a little easier for you with the change of base form, and you have lots of space there. And hopefully you found, but my little note to you in the beginning of the Nearpod would have told you that you're going to have to hunt around. And actually, I'll make sure that it tells you what page, because the rest of the lesson was on the other pages. Actually, when I post this, I'll start with this one, with the change of base formula, and then the other ones. And so I'm telling you now, when you see the next podcast, the notes that you're going to need are on the third to last and second to last pages, all right? So it's not exactly in order of your notes. However, I did make sure that what you're going to need the most was closest, in terms of solving exponential equations and log equations, was closest to that particular type of equation. But for this lesson, I packaged them all together. So you'll just have to hunt. This one will be the first one. And then I have a nice little intro to 3 other properties that you'll learn. And I think this might be my last one. And it is, right? So ignore that. So this was the last one. So now in the next podcast, you're going to have to turn the page to the third to last page. And but after the intro, there'll be some notes on power rule, product rule, and quotient rule. And those we're not going to use. Power rule comes into play in solving exponential equations, and I'll explain that when we're exponential equations that have different bases, and I'll explain that when we get to solving exponential equations with different bases. And then the product and quotient rule, though, we're not going to use till we solve logarithmic equations, right? So you won't use all the properties at once, but I did put them all together in the lesson. All right, so thanks for watching this one, and I hope you found the change of base formula super easy. I think it is, and it makes a lot of intuitive sense, which is why I do that whole thing, like the whole check yourself by asking if the answer makes sense. And you don't have to do all of this each time, certainly not. But if you look at an answer and it doesn't make sense, stop for a moment and just think about it. You know, does your answer make sense in terms of where that number is located between two numbers that you do know the exponent for. Like in this case, 5 squared is easy, 5 cubed is easy, anything that's an integer is easy, right? And then you can see, does your answer fit with known values of some base raised to a power? Anyway, that's the end of this podcast. Thanks for watching, and I hope you enjoy some more properties of logarithms coming up in the next lesson. Pay real close attention, by the way, to the opening. It's, I think, going to help you understand a whole lot better a couple rules related to logarithms. All right, bye for now.